In this lesson, we'll be learning about magnets and magnetic fields. So we'll start by talking about magnets. Now, magnets and the property of magnetism has been known about for thousands of years. Sailors have used magnets in what are called compasses to find the directions north, south, east, and west for a very, very long time. And it was known that there are certain minerals like lodestone that have these strange magnetic properties. Now, magnets themselves, we're going to think of as probably the simplest magnet is a simple bar magnet. So it's a simple bar where one side has a pole we're going to call north, and the other side has a pole we're going to call south. Now, north and south are arbitrary designations, just like positive and negative charge were arbitrary designations. There are two poles, we've just given them the names north and south, and the reason for that is because we'll learn later Earth is actually a giant bar magnet, or at least it acts like a giant weak bar magnet, where one of the magnetic poles is near the geographic North Pole, not quite on it, but close, and the other pole is near the geographic South Pole. So, all magnets have a North Pole and a South Pole. Like poles repel one another. So if you bring two bar magnets together, where they have, imagine the tips of these markers are the north poles of a bar magnet, when you bring in these bar magnets, they'll want to push apart, just like charges repel. If you bring in two positive charges together or two negative charges together, they push on one another. Alternatively, right, unlike poles attract, just like opposite charges attract. A positive charge attracts a negative charge, they pull together, just like a north pole and a south pole attract one another. Now, this attraction and repulsion is very useful, especially thousands of years ago, because the Earth itself acts like a giant bar magnet. We'll learn later why that is. But Earth has a north pole, Earth has a south pole. So we can use another magnet. Imagine a small needle that's magnetized, placed on a floating bit of cork in a little pool of water, or a little free axis on the needle itself, allowing the needle to spin. If the needle is magnetized, the needle's north pole will align to the Earth's magnetic south pole, and the needle's south pole will align to the Earth's magnetic north pole. So you can always tell direction, which way is north, which way is south, using this simple compass. Now, most of us have slightly more sophisticated compasses in our cars and smartphones nowadays, where most GPS devices are able to determine what direction you're facing using the Earth's magnetic field. If the Earth did not have a magnetic field, these GPS devices wouldn't work, at least insofar as being able to determine what way you're pointing. Additionally, humans are the only species to use a magnetic field. Many birds, when they migrate north and south, actually follow the Earth's magnetic field. They know which way north is or which way south is because of the magnetic field of the Earth. Now, unlike charges, where you can have a positive charge by itself, or you can have a negative charge by itself, north and south poles always occur in pairs. Always, always, always. There is no such thing as a north pole that's by itself or a south pole that's by itself. So for instance, if I were to break this, if I cut this in half, the resulting object I would get is I would get two magnets, each with a north and south pole. Now I can cut those in half, and then I would end up with four magnets, each with a north and south pole. And that continues on until you can cut it down to the individual atoms themselves. It can be thought of as having a north pole and a south pole for those atoms that have magnetic properties. So this is the concept of magnets. You've probably played with magnets. All of you, I'm sure, have used magnets at some point in time. Refrigerator magnets, the Hard drives for older computers, the ones that have the magnetic platter, the spinning disk. It's a magnetic disk that stores your information. Old, of course, cassette tapes are magnetic strips storing information. Credit cards, when you swipe credit cards, on the back is a magnetic strip that stores the information, although modern credit cards are now going to the chip system rather than just the generic swiping the magnetic strip for security issues. So this is concept of magnets that we'll be focusing on in this chapter, and we'll continue to talk about magnets and the magnetic fields in subsequent lectures.